Alright, so let's look at these questions we have from Connect Math. The first one here says to multiply the fractions and simplify to lowest terms. So this is number 8. We have 35 over 48 times negative 6 over 5. So what I can do when I multiply fractions is I'm going to multiply across the top and multiply across the bottom. I'll come up with a new fraction and then I simplify. So I could do that. 35 times negative 6, put the answer. 48 times 5, put the answer. But instead, what I can do here is, because I can see that 35 and 5 have a common factor that will divide out. That common factor is 5. So I can divide that out, and that'll give me 7 times negative 6 and 48 times 1. Then I can say, well, wait, 6 and 48 also have a common factor that will divide out. That's 6. That will give me 8 here and 1 here. So now I'm left with the numbers that I wrote in here. 7 times, and don't forget the negative sign here, negative 1, so negative 7, and 8 times 1. And then I don't have to work with the big number to simplify. I can just write negative 7 over 8. Where if I did not simplify as I was multiplying, then I would end up with, let me put this in the calculator, 35 times 6, which is 210, and 48 times 5, which is 240. And don't forget the negative sign, because this was a negative 6. Then from here, I would have to say, okay, well, both of these are divisible by what number? Well, I know I could divide out a 10. So, and you don't normally write the 10, I'm just writing it to show you what I'm thinking. So dividing both of them by 10, I'd get negative 21 over 24. I knew they were divisible by 10 because they both ended in a 0. Then I can say, okay, 21 and 24, those have a common factor of 3. So dividing out 3 from both of those, I would get negative 7 over 8. So now 7 and 8 don't have anything in common, any factors in common, so that's where I would stop. So that is how I do number 8. Number 17 here says that you have, so the first one, the loaf of bread originally sold for $1.74 undergoes a 7% price increase each year. Find the new cost after 10 years. So for number 17, I'd write an exponential. This is exponential growth because it increases by a certain, that same percentage. So I would take the original cost and I'd multiply it by 1.07, the 7% written as a decimal, and then add 1 to it, raised to the number of years, so 10. And so that is correct. So you end up with $3.42. Then it says, if, on the other hand, the cost of the loaf of bread increased by 7% of the original cost for 10 years, how would that compare to your answer from part A? So let's see the difference here. This says increase by 7% of the original cost each year. So 7% of the original cost. So 7% of the original cost would give me then it tells me to round all intermediate calculations and the final answer to the nearest cent. So this is a intermediate calculation. So I have to round this to 12 cents. And that means each year it's going to increase by 12 cents. So I'm going to take and add 12 cents for 10 years. Or what I could do is multiply that by 10. It's the same thing as adding 12 cents 10 times. So I get $1.20. So the increase would be $1.74 plus $1.20, giving you a total of $2.94 after the 10 years. So after the 10 years, it'd be $2.94. So it wants to know the original cost of bread would be you had to choose more or less, and then how much. So take $3.42 and subtract $2.94. You end up with 48 cents. So put in 48 cents, and this is 48 cents less. All right, let's look at 21. So for 21, we have 6 raised to the negative 2 power. And we want to give an answer. So exponents, the rule for exponents that are raised to a negative power. So this is just in general. If I have x to a negative n, it's 1 over x to the n. So the negative sign in front of the exponent doesn't make the base negative. It flips where the base is. So since the base, we don't write this over 1, but you can. Any whole number can be written over 1. If the base is in the numerator, it's going to flip to the denominator and become a positive exponent. So it's 1 over 6 squared, or 1 over 36 when I go to simplify for 21. And then last I have number 22. And for 22, I have this number that is a large number, and it asks me to write it in scientific notation. So whenever I do this, I'm going to say I need to pick a number between 1 and 10 for the front number, and I don't want to round this because then I miss these digits. So I'm going to put my decimal here. I wouldn't want to put my decimal here because then I would have 35 as my number. I wouldn't want to put my decimal here because I would have 356 as my number. But it's appropriate to put your decimal there. And then I don't have to put all these zeros here because the zeros at the end don't change anything. So instead, I will just put the digits that are non-zero, and then I'm going to put times 10, and then I'm going to count. This is 1, 2, 3, 4, 5, 6, 7 places. So I put a positive 7. Positive exponents are for large numbers. Negative exponents represent small numbers. So if I had a number like this, that's a very small number, and I write it in scientific notation, my exponent is going to be negative. So sometimes some books will say, well, move it to the right, move it to the left, depending on how you're looking at this number, and you have to remember, okay, it's a positive or negative. This is the way to do it. This is the way, if I have got a large number, 35 million is a large number, I keep my exponent positive. If I have a small number, my exponent's negative.